Hey flight simmers, welcome back to my channel. I'm the cockpit printer and today is part 2 of the Korry Switch. In the last video we already did the 3D design of the Korry Switch in Fusion. There was a bit of confusion about this second ring on the Korry housing. The first ring on top, it's quite obvious, it's the support for the halo ring. And the second ring is to keep it in place inside the bottom panel. And as you can see here, there is the negative inside this panel, and we can insert the Korry into the panel, and here is a nice flat surface from the side where we are able to place the LED strips like this. And I added the two chamfers because with the chamfers I'm able to print both of the rings without the need of any support structures. Later we will see that we're just inserting the Korry in the bottom panel and add the top and now the Korry stays in place without the need of glue or screws or something else. And that's the reason for the two-ring design of the Korry Switch. Today we will first print all the parts of the Korry Switch, and afterwards we will focus on the assembly. We will do the full wiring of the Korry Switch, and then we have a look into MobiFlight, and I'm creating a little test environment to test my Korry Switch. In the future, when I'm creating all the different kinds of Korry Switches, I'm able to check them really quick without starting the flight sim every time. For this, I'm creating this little test environment in MobiFlight. My supporters on Patreon will find all the data of the Korry Switch on my Patreon page, the STL files for printing, the Bamboo Studio projects as well. Just load it into Bamboo Studio, send it to your printer, and don't care about any of the parameters. These are the projects I actually printed on my printer, so they're working just fine. You will find the MobiFlight profiles as well. Just load it into MobiFlight and test your Korry Switch. If you are new to the channel, please make sure that you subscribe and hit the bell. But for now, just grab a cup of coffee and let's get to work. Let's start with the printing. We haven't exported all the STL files yet. Let's do this first. Go back to the design document of the Korry Switch and open up the button to the bodies folder. Save the button as mesh. Browse to the directory you want to save it. Go on with the housing. The halo. And the cover. We have to export two STL files, the black one and the transparent. Let's start with the transparent. Select the clear body, save as mesh. And for the black STL, because we have several bodies over here, switch the visibility of the clear body, select the cover, right click, save as mesh. Everything that's visible will be exported. Save it, and now we go into Bamboo Studio and do the print. Here we are in Bamboo Studio. I already created a new project and I will add the STL files, press add, browse to the directory where you stored the STL files to. And let's start with the button, the halo and the housing. I don't want to use to load it as a single object. Right click and set the filament to black. For the halo, I will create a new plate and drag it over here. I don't want to print it on one plate because otherwise we will have a lot of filament changes and it takes time. Just print it on a separate build plate. And one more build plate for the cover. Select both of the STL files, but this time I want to load it as a single object. Press Auto Orient to place it on the large face and change the filament to black and clear. Now I've set up 3 build plates, one for the housing and the button, one for the halo ring. The halo needs to be changed to filament, clear. And let's start with the housing and the button. Just press slice plate and I'll have a warning. The housing has floating cantilever. That's because I have the strain relief on the lower end and I have to add some support structures. Go back to prepare, select the housing and over here support and enable support. The style to snug. Slice plate again. The warning doesn't appear anymore. That's great. And now I've added some support structures. And inside the strain relief, there is a little bit of support structure as well. And from time to time, it's a little bit hard to remove this support structure over here. And for this reason, I don't want to have the support in the strain relief. To remove it, go back to the prepare page, select the housing, right click and add a support blocker. A cube. Here is a cube. Change the size with scale. And move it into the right direction, or to the right spot over here. Slice it again. And now no support structure is generated in the strain relief. Great. The walls of the housing and the button are just 1 millimeter. And here you can see it's just 3 lines. And I will change this, that I will have some more lines. And I will want to do this as well for the button, for the halo ring and the cover as well. And I can either do it manually for each component by selecting it and quality set the line width. But in order, or I want to change the line width for all the components, I will set it in the global settings. Inside there, you find the quality page. By default, it's 0.26. The initial layer, I will set, or don't change it. I will keep it at 0.5 millimeters, but all the other values I'm changing to 0.26. slide the plate again. And here you can see there are much thinner lines. But in the initial layer, there's still the larger line width, and this avoids some adhesion problems. That's the reason why I keep the 0.5 millimeters on the initial layer. All right, this build plate is finished. If you want to create several clones, 9 clones of the button, 9 clones of the housing, and nice about the clone feature, it clones the support blockers as well. And with this, you can print several Korrys on one build plate. Okay. Send this to the printer and it will start automatically. When it's finished, remove the parts from the build plate and go on with the halo ring. The halo ring, I will add a brim, select the halo, and on the others page, the brim type I will set to outer brim only. And here this brim is generated and increases the contact surface with the build plate. And now the halo is ready for printing. Press print plate, send it to the printer. And for the cover, just press slice plate. We have the thin line width already set on the global parameters. And just send it to the printer. And when all the prints are done, we can go on with assembly. Let's talk a little bit about the circuit board inside the Korry Switch. And I will start with the LEDs. Here I'm on the page of my local supplier here in Germany. And I will always just use LEDs with 5 millimeters of diameter. But there are some values you have to consider. For example, the angle of radiation. There are different values, 15 degrees, 40 degrees, 60 degrees. And I will recommend to have an angle of radiation at least 40 degrees, because otherwise you will just have a little or just a bright spot in the middle of your of the text and the rest is dark. And with a larger angle of radiation, the light will illuminate in a much brighter angle. Then you have to be aware of the light intensity. It's measured in MCD, and it's actually not the direct brightness of an LED. It's a value for the light particles the LED will emit. And it's even possible that an LED with 10 MCD is brighter than an LED with 1000 MCDs. It's depending on the angle of radiation. An LED with an angle of radiation of 15 degrees and 100 MCD, for example, might be brighter when you look on from the top than an LED with 60 degrees of radiation and 250 MCD. I will recommend to have a light intensity with an angle of radiation of 60 degrees by at least 1000 MCDs. Let's filter the list for the angle of radiation, 60 degrees. And the light intensity. Not that much in the list, but let's scroll through it. Yeah, here you have a blue LED, 1000 MCD, 60 degrees, angle of radiation, a green one with 3000, and these LEDs will be just fine, red with 1500. And if you have selected an LED, there are some values of the LEDs. Let's have a look on the schematic. This is just a simple schematic of my circuit board. Here you have both of the LEDs, the upper one, in this case the Korry Switch from the APU, the away light, and on the bottom on. And for this I will select a green LED on top and a blue on the bottom. And both of the LEDs need a resistor in front. From one side there is the plus 5 volts from the Arduino board supplied, but you always need a resistor before the LED, because the LEDs are operating with a voltage, in this case maximum 2.3 volts and a normal current of 20 milliamps. These are two very important values, and with these values you can simply calculate the resistor. You can do it with the usage of Ohm's law, and back in school I never thought that I will use it again in my life, but this is a really good application for this, and it's pretty simple. Open up the calculator, and again from our Arduino board we will get 5 volts. Then we have to subtract the operating voltage of the LED, 2.3 volts, 2.7 of course, and with this voltage we can simply calculate the resistor, and just by dividing it by the forward current, 30 milliamps, dividing by 0.03 is 90 ohms. If there is no resistor available in this with this value, just select the next larger value for the resistor. I've ordered 100 ohms because it's usable in other applications as well. Yeah, I selected 100 ohms. And this is a very simple way to calculate the value of the resistor. And this is just a simple pattern. For the lower LED, we will have 5 volts. It travels through the first resistor into the LED, and from there to the ground. And from the other side, for the upper LED, from this direction to the second resistor as well. And both of the LEDs will share one ground pin. Let's start with the assembly of the Korry Switch. What do we need for the assembly? Of course, the printed parts. I printed the Korry Switch in the muted blue color. It's the second time I'm recording this video. The first time I printed it in black, but you don't see anything of the details because of the contrast. So I printed it in muted blue for this demonstration. We need the little switch. Then two LEDs, the green LED and the blue LED. And for the LEDs we need two resistors of 100 ohms. And of course a circuit board we can solder the LEDs to. I already cleaned out the Korry Switch. I removed all of the excess material and the support structure. And now we can go on with the assembly. Let's start with the button itself. When I try to push it into the housing, it's a little bit tight. And I'm using 200 grit sandpaper to clean the cylindrical surfaces of the button. And now it runs really smoothly. I can try if the switch fits into the button. It should be connected with a little bit of pressure. If that's not the case, you can try to clean it out a little bit with a knife. Okay, that's nice. Be careful, don't apply too much pressure to the switch, otherwise it will take damage on the inside, but that's just fine. Let's plug the switch into the housing. And insert the button. Make sure that the slots are aligned. Now we have assembled the Korry Switch, or the halo is missing. Okay, let's go on with the circuit board. I already marked a field of 5 by 5 pins and the center of it. And now I will place the components like you can see on the wiring schematics. I will start with the LEDs, and the LEDs you have to be careful because you have to place it with the right polarity. The LEDs have a longer and a shorter pin, and the longer pin is always the positive side and the shorter pin the negative side. And I will place the pins with the shorter pin, the ground, towards this center pin, and they will share this center pin for the ground. This is a blue LED, and do this as well with the green LED, the shorter pin to the inside, plug it into the circuit board, and just give the pins a little bend so that they are fixed in place. And then solder the LEDs to the board. And then cut the pins. Let's go on with the resistors. Bend it like this and insert it into the holes. And I will follow the wiring as you can see in the schematic. The top left hole is the plus 5 volts from the Arduino for the blue LED. And for the green LED, I will insert it like this, that the bottom right hole is the plus 5 volts from the Arduino for the green LED. Like I did with the LEDs, just bend the pins a little bit and solder it to the circuit board. Now, before you cut all of the resistor pins, I will use the resistor pins to connect it to the LEDs. Just bend it over so that this resistor of the blue LED, the pin, connects to the LED. Now the components are in place, and let's go on with the wiring. I will start with the black wire for the ground. And I will use a piece of about 12 centimeters. Strip the end. In this case I will strip it a little bit longer than usual. Just about a centimeter or so. Plug it into the middle between the two LEDs. And bend it over so it's just locked in place for now. Then add a little bit of solder to the pad. And then I will connect all the ground pins with some solder to the middle pin. Like this. So now both of the LED ground pins are connected to the black wire. And now I will heat it up again and push the wire into the board until the isolation is aligned with the solder. And now just cut the excess material. Let's go on with the blue LED, and I will recommend to use wires in the same color than the LED, because we need a lot of Korry switches with different combinations of LEDs, and you can see just by the wires which LEDs are mounted inside. Again, just a piece of 10 centimeters, strip the end, insert it into the board. But like we did with the ground, for now just a little bit. Solder it to the pad and link the pad to the resistor and then push the wire into the board. And cut the excess material. And the green wire for the green LED. And connect the two pads, the resistor and the wire. And now the green wire is connected to the resistor. Before I cut out the circuit board, I will test it. For this I will strip the end, but just a short piece. I will not remove it all the way. And now I will use my Arduino board. I connected the wires plus 5 volts and the ground. And I'm connecting to the ground. Let's try the green LED. And if I connect it, you can see that the green LED lights up. And the blue LED is lighting up too. If it isn't the case that your LEDs are lighting up, that may have the reason that the pads are not connected with each other, or your LEDs doesn't have the right polarity. So make sure that you have the right polarity and connected the pads with each other. Okay, now I've checked the circuit board. Let's cut it out. For this I'm using a simple metal saw. Let's give it a test. Right now it doesn't fit into the button. I have to remove a little bit of material off the circuit board. Now it fits into the button. Now I'm bending all the wires to one side that I can feed it through the slots. Add a small piece of heat shrink tubing right next to the housing. Now I'm creating a little arc like this. And add a second piece of heat shrink tubing. And now I'm creating a full loop and fix it to the strain relief with a cable tie. But for now, don't tighten it up completely. We first do the connection to the switch. For this I will cut the wire pin or the wire for the ground to length, and I will use these the two pins on the lower right. When the button is pressed, these two pins will be connected, and I will use the lower pin for the ground and the upper pin for the signal. I'm using a second short piece of black wire and connect it to the other one. add some solder. Add a little bit of solder to the soldering iron and connect the wire to the pin. All right, now I will use a piece of gray wire for the signal. Again with a small piece or a little bit of solder on the tip, just connect it to the second pin. And now I'm feeding both of the wires through the cable tie. And now tighten the cable tie. Cut all the wires to length. And now I'm adding a connector to it. For this I'm using my DuPont connector kit. A 4-pin connector housing and the female connector pins. For the placement in the housing, I will use always the same pattern. On the left side, where this little arrow is on the housing, there's always the ground pin. Right next to it, the signal of the button. Then next will be the lower LED, because not every Korry has two LEDs, and the last one is the upper LED. And now with the wires, I will always be able to recognize which LEDs are mounted on the inside of the Korry switch. Now we can go on with a connection to MobiFlight and to the flight sim. Let's connect the Korry to the Arduino. For this I'm using this wire I made with the DuPont connectors, one 4-pin connector on one side and a 3-pin and a single pin on the other side. The single pin is connected to ground. and I will connect the 4-pin, as you can see here, the black wires for the ground, and then gray, blue and green for the signal, and the 2 LEDs. And I'm connecting it to the Arduino, black to ground, and signal of the switch to pin number 8, the blue LED 9 and the green LED pin number 10. Let's go into MobiFlight and let's do the connection in there. And right now I will just create a little test environment to test the functionality of the Korry Switch. The plan is just to press the button and both of the LEDs will lighten up. For this I will go into the MobiFlight modules and add a device, a button to pin number 8. Simply name it button. Another device, an LED output to pin number 9. It will be the lower LED, and a second LED output, the upper LED on pin number 10. Upload the config. Let's go to the input configs, add a new row. We'll name it Korry button. Go to edit, select the module and the device, and on press the action type. I will store it in a MobiFlight variable. Name it Korry, and here I will give a fixed value. In the past, when we worked with potentiometers, we added an add symbol in here because I wanted to store the value of the potentiometer in this variable. But now I will assign a fixed value to it. If I have an on press event, I will assign a 1 to this variable, and on release the MobiFlight variable and Korry again, and set the value to 0. On press, Korry to 1, and on release, Korry to 0. Hit OK, and let's go to the output configs, add a new row, and name it lower LED test. Go to edit, select the MobiFlight variable, Korry, and display, select LED output, and select the lower LED. We can test it in here, just give it a value, 1, and test. As you can see, the blue LED lightens up, 0, and it will stop. All right, hit OK and press run. And now when I switch or press the switch, I'm in the on press event, and it's the variable in state 1. The LED lightens up, and when I release the switch, the variable sets to 0. Now I could add another row or duplicate that row and name it upper LED test. And just set the display settings to upper LED, hit OK, and when I'm running this configuration and press the button, both of the LEDs will lighten up. But there is a much easier way. I delete this row. This one I will just name LED test. And here I'm able to trigger both of the LEDs just by select multiple outputs and select the lower and the upper LED, hit OK. And now both of the LEDs work just fine when I press the button. That's a very simple test environment to test all the Korry switches in the future I'm about to make. It's not necessary to connect it to the flight sim directly. I will just use this configuration to test the Korry switches. This is the end of part 2 of the Korry switch. Today we printed all the parts, did the assembly and the wiring, and after that we connected the Korry switch to our test environment in MobiFlight. As you have seen, right now I added the DuPont connector to the Korry switch and not the full wire directly, and the reason behind this is that I don't know about the exact length I will need later. And if I'm adding the full length of the wire directly, in the future it's either half a meter too long or 1 centimeter too short. And for this reason I just added the DuPont connector right now, and later when I do the assembly of the overhead panel, for example, I know about the exact length I need to link the Korry switch to my Arduino board, and I will create the wires to connect the Korry switch to the Arduino later. I made the decision to make a third part of the Korry switch, and in the next video we will have a look on the covers of the Korry switch. We already designed it in part number 1, but we have to create several different types of the covers, and I will show you a very quick way to design all of the different covers, how to print it, and finally how to mount it onto the Korry switch. It will be a rather short video, but I made the decision to make a separate video out of it. Again, if you are new to the channel, please make sure that you subscribe and hit the bell. If you find this video helpful, please give it a like, and see you in the next video.